Hi, and welcome to Chapter 2, The Structure of Matter. We will be working out of your Bouchon book today. If you would flip to Chapter 2, and take a look at the first portion and the objectives and outline. When we start to get into physics a little further, we're going to get into binding energies and how X-ray photons are created. So it's really important to understand the basics out of this chapter. We've talked a little bit about matter in Chapter 1. We know that it has a mass, it occupies space, that there's a mixture of substances that create different combinations and different mixtures. And this is what we look at when we're taking a look at the tungsten and the interaction that's taking place on the anode. Substances are either going to be simple or they're going to be complex, and basically the element can be broken down into simpler substances. The small unit of that element is what we call an atom. So there are 92 natural occurring atoms or elements, and when you take a look in your chapter, be sure to concentrate on that periodic table. We're really focused on what's going on with barium, hydrogen, and so there's certain ones that I'm going to need you to be able to recognize, and that will be on the homework assignment that I'm going to attach to this file as well for you to take a look at. So in matter, a compound is two or more chemically bound elements. The smallest unit is going to be called a molecule. So you'll see this with salt, water. This is important when we start taking a look at contrast media and what it does and how it produces an image on our films. So you're going to be studying this next semester with Cindy. You'll actually get into that breakdown, what type of reactions can occur because of the body's reactions to different combinations. And so it's important to understand that chemical breakdown for when we get into that portion. Back in 1913, a Danish physicist named Niels Bohr actually made the first miniature solar system, and it was that model that we are using now when we're talking about that atom. So when you take a look at the center of your atom, you have your nucleus, and then you're surrounded by your orbiting electrons. So there's three parts of that atom that we need to be familiar with: that electron, the proton, and neutrons. Atoms at the nucleus are going to be made up of your protons and neutrons, and the electrons are going to surround that outer shell. When we take an X-ray, we're shooting across those electrons, and we can actually kick out an electron in that atom of the tungsten atom. And that energy creates our X-ray photon. We can also have combinations that take place up by the nucleus, and there's certain types of X-ray photons with different types of energy that can be created at that point as well. So each shell is going to contain a maximum number of electrons that it can hold. So we actually have a formula that we can use, n being the shell number. So if you take 2 times n squared, you'll get how many can be held in each shell of that atom. So for an example, your K shell has the number 1. So you take 1 squared times 2, the maximum number of electrons it can hold is going to be 2. The L shell, same concept, it can hold up to 8, and the M shell can hold up to 18. There's a chart in your book that has something that looks like this. You do need to know that mass in kilograms for your proton, neutron, and electron. You also need to know the atomic mass unit and that electrical charge. These are pretty easy to remember. The negative charge we know an electron has. Protons are going to have a positive charge, neutrons neutral. But the mass in kilograms, the proton and neutrons are exactly the same, and then your electrons is 9.1 times 10 to the negative 31st. So I'm more concerned with you knowing this portion and this portion of this chart. Each shell or orbit is going to have the binding energy, and again, this is what's important for us to understand because this is where the X-ray photon is going to be created. So this is the amount of energy that's going to be needed to eject that electron from its orbit. So the closer we get to the nucleus, the more energy that's going to be released, and that will have a higher energy photon created. So your K shell is going to be a stronger bond than your L shell would be. So the closer to the nucleus, the more binding energy that's going to need to eject that electron. So your tungsten atom, it had a K shell of 70 kiloelectron volts. And in your book they actually have a breakdown of that. I do need you to know K-shell for the tungsten atom, 70 kiloelectron volts, because the majority of the discussions that we're going to talk about in the future will be in reference to that K-shell because the binding energy is so great. A neutral atom has the same number of protons and electrons, so when an atom gains or loses an electron, it's called an ion. When that atom gains one or more electrons, it's going to have a negative charge, which is an anion. When an atom loses one or more electrons, it's going to have a positive charge, or a cation. So in that periodic table, there's actually one in your Carlton Adler that you can use, or you can go out and reference the web. It doesn't matter to me which one you use, but I do want you to know the following: aluminum, calcium, iron, yttrium, hydrogen, oxygen, molybdenum, iodine, barium, tungsten, lead, cobalt, nickel, and radon. So make sure that when you're taking a look at your chart, you know where to find those on the periodic table. So on your periodic table, I also want you to take a look at those and know what the atomic number is, know what the atomic mass is. So this is your number of protons plus the number of neutrons. So an atom that has gained or lost a neutron was going to be called an isotope. And if you remember in the last chapter, we started talking about isotopes and radiation. So your hydrogen, deuterium, tritium, this is actually used in nuclear rods, so you're going to see these at your nuclear facilities. Those isotopes are usually unstable, and when they decay, they actually produce off gamma radiation. That's why they're so dangerous when you take a look at some of the facilities that have been abandoned. The number of electrons in an atom's outermost shell is the ability to bind with another. This is called the valence. So again, when you take a look at those ones that I've given you on the periodic table, take a look at what is the valence number. So your periodic table, just take a look, see if you can figure out on your own what's magnesium and what's nitrogen's valence numbers. So your ionic bond is when one or more electrons move from one atom to the other, and the results in ions attracting. We see this with table salt. Covalent bond is when two atoms share electrons, so the electrons can be in either orbit. So this is your water. Covalent bonds that tend to be stronger than ionic bonds. So again, when you take a look at your chapter, I want you to read through your chapter 2 on the structure of matter, focus in on that periodic table, and go through, and I'm going to have that homework assignment in the Dropbox. I want you to go through and answer the questions that I have throughout the table. And then you can bring back any questions that you have the next week in class, and we can go through that and make sure you have a good understanding of the material.